Hello, I am Nisargee Raval,
And I am Vaidehi Desai.
and along with our teammates Manav, Patel, and Prachi Chauhan, we have made a website on page replacement algorithms. You can know more about us here. You can also reach us through our Gmail by clicking on this ID. We have created this project with the help of our ma'am Sonam Nahar. This is our home page. We have explained what is paging. Paging is a memory management technique which allows usage of virtual memory and eliminates need of continuous memory allocation. Thus, we have non-continuous memory allocation in the physical address space. Since we have limited number of frames allocated to a particular process, we might need to swap some pages out to bring the required pages, and for that we need page replacement algorithms. Now let's move on to the four algorithms. First is FIFO, that is first in, first out. In this algorithm, the operating system maintains a queue that keeps track of all the pages in the memory, with the oldest page at the front and the most recent page at the back. When there is need for page replacement, the FIFO algorithm swaps out the page at the front of the queue, that is the page which has been in the memory for the longest time. We have also written algorithm for the FIFO. We have also listed advantages and disadvantages here along with the references if you want to know more about this algorithm.
Here, we have also created a simulator which shows the process of the algorithm first in, first out. Let's try it with an example. We have to enter the reference string and number of frames for which the algorithm shows the output. So, in this simulator, we have to enter the reference string and number of frames. Here, we consider this example with three frames. And let's see what it gives in the output. So here we get the requested page hit or miss, and frames in page table for the respective entry. For the request of 0 and 1 and 2, there will always be a space available in the page table, and so it will be directly inserted into the page table and it will be a page miss. Now when the request of page 3 comes up, one page must be swapped out to bring it in because there is no more space left in the page table. So the oldest page added in the memory, that was 0, will be replaced by 3. Similarly, when again 0 is requested, 1 will be the oldest in the page table and it will be replaced by 0, and it will again be a page miss, and so on. When again 0 comes up, it is already present, so it will be a page hit. Similarly, we see the algorithm. Now, in this case, we encountered total of 9 page faults, and thus our page fault rate becomes 0.75. Now, FIFO is subjective to Belady's anomaly. What is Belady's anomaly? We expect the number of page faults to decrease when we increase the number of frames. But sometimes, for some inputs, this doesn't happen with FIFO. So let's try with the same reference string and different number of frames. Last time we took 3. Let's try with 4 number of frames. What we observe here is the number of page faults is 10 in this case, which was 9 for 3 frames. We increased the frames, but the page faults also increased. So we can see the Belady's anomaly here. Let's move on to the next algorithm.
Next algorithm is LRU, that is least recently used. It keeps a track of a page usage in the memory over a short period of time. It works on the concept that pages that have been highly used in the past are likely to be significantly used again in the future. It removes the page that has not been utilized in the memory for the longest time. Here we have written the algorithm, advantages and disadvantages, along with the references.
Now, here we have also created a simulator for LRU, and we have to enter the reference string and number of frames for which it simulates the algorithm. Let's try with an input 1, 2, 3, 2, 1, 5, and 3 number of frames. Let's see. So here we get the output as shown. Now, when the first 3 requests come up, there is space available in the page table and the pages do not exist in the page table already. So we directly insert the pages in the page table and it will be a page miss. Now when the request for 2 again comes up, it is already present in the page table, so it will be a page hit. Similarly, when the request for 1 comes up, it is already present in the page table and it will be a page hit. Now when request for 5 comes up, it is not present in the page table and we must swap out one page. Here we have used 1 very recently, 2 very recently, and 3 is the used 3 is the page used farthest in the past, so it will be replaced by 5, and we see here that 3 is replaced by 5 here. And total number of page faults in this case was found to be 4, and page fault rate was 0.67. Now let's move on to the next algorithm.
Our next algorithm is OPR, that is optimal page replacement. As the name suggests, it always gives the least number of page faults for any input. If a new page is already present, it is used. If a new page is not present and there exists a page that is never referenced in the future, it is replaced with the new page. If no such page exists, replace the page that is referenced farthest in the future with the new page. We have shown the algorithm advantages and disadvantages here. We have also listed the references.
Now, we also have created the simulator for optimal page replacement and we'll see it with an example. So let's consider a reference string that is 1, 2, 3, 4, 5, 2, 3, 4, and with 3 number of frames. So this is how the optimal algorithm works. When the first 3 requests come up, there is a space available in the page table and the pages do not already exist in the page table. So they will be directly added in the page table and it will be a page miss, as we saw for the other algorithms as well. Now when the request for 4 comes up, we see that in the future requests, 2 is required for the first, then 3 is again required, but 1 is never required again in the future. So 4 will replace 1, it will be a page miss. Now again when the request for 5 comes up, it is not present in the page table and we see that 2 and 3 will be required in future, but and 4 is also required in future, but 4 is required farthest in the future, so 4 will be replaced by 5. Now, when two request for 2 comes up, it is already present in the page table and will be a page hit. Similarly for 3, and when the request for 4 comes up, 5 is never used in future. None of them is used in future, but 5 is the first one, so we replace it with 4 and it will be a page miss. Here total number of page faults is 6 and page fault rate is 0.75. Now, let's move on to the next algorithm, which is our last algorithm.
That is least frequently used. It is also called non-frequently used page replacement algorithm. In LFU page replacement algorithm, the page with the least visit in the given period of time is removed. It replaces the least frequently used pages. If the frequency of pages remains constant, the page that comes first is replaced first. We have written an algorithm for it. We have listed the advantages, disadvantages, and references here.
We have also created a simulator for the same and we'll see it with an example. So let's consider a reference string that is 1, 1, 2, 3, 2, 2, 3, 4, 4, 4, 5, and with 3 number of frames. For this algorithm, we see this output. When the request for 1 comes up, it is not present. It will be a page miss and it will be added into page table. When again request for 1 comes up, it is already present in the page table, so we use it and it will be a page hit. Again, when request for 2 and 3 comes up, they are not present in the page table and there is space available, so they will be directly inserted and it will be a page miss. Now, when request for 2 comes up, it is a page hit because it is already present. Again, for the request of 2 and 3, it will be a page hit. Now, when the request for 4 comes up, it will be a page miss and we have to replace some page. Now, according to the least frequently used, we see here that 1 was used twice, and 2 was used thrice and 3 was used twice. So one is used twice and 3 is used twice. Both are used for the same number of times, but we saw that when this case occurs, we replace the one which was added first. One was added first here, so it will be replaced by 4 here, as we see. Now when the request for 4 again comes up, it is a hit twice, and when the request for 5 comes up, we must replace one page, and we see that the frequency of 3 is least, that is 2. 2 and 4 are used thrice and 3 is only used twice. So we replace 3 by 5. And here the total number of page faults is 5 and page fault rate is 0.45.
We have also created a feedback panel where you can write to us if you feel good about our website or want us to add something more.
And that is all from our side. Thank you.